Everyone. So this is our DL hackathon final presentation. So our project topic was heartbeat anomaly detection. So the problem statement is to detect the abnormalities in the heartbeat to classify the abnormal heartbeat into four abnormal categories. We have artifact, extra systole, extra heart sound, and murmur. So we record. So we have a data set which has a audio file which has been taken from Kaggle, and in the dataset we have two CSV files. Set A includes labels and metadata for heartbeat levels collected from general public via an iPhone app known as Stethoscope Pro, and the second is labels and metadata for heartbeats collected for clinical trial in hospital using digital stethoscope. So we have an audio files which are stored in WAV format, and they start from 1 second and 10 second of lub and dub of the heartbeat. Data set is also biased toward normals. We have total 375 audio files, and we can see what is the normal heartbeat. A normal heartbeat has a clear sound of lub dub and lub dub pattern, which is from time to time lub dub shorter, and then the time from dub to the next lub. And again we have then artifact heartbeat. In this category there is a wide range of different sound including feedback, sequels, echo, speech, music, and noise. If someone gathering the data gets an artifact heartbeat, he should try again. So third one is murmur. Heart murmurs sound as though they are whooshing, groaning, rumbling, or turbulent for noise in one of the two temporal locations between lub and dub and between dub and lub. They can be a symptom of many serious heart disorders. So another one is extra systole. Extra systole sounds may appear occasionally and can be identified because there is a heart sound that is out of rhythm involving extra skipped heartbeats. Example is lub lub dub or lub dub dub. It can happen normally in adult and can be common in children. However, some situation of extra systoles can be caused by heart diseases. So our data set distribution is this. As I have said, our data set is biased, so you can see the extra systole files are very less compared to we have 6 files of extra systole, and for normal we have many files. And going for the methodology, so we feed our first we have taken the audio files and we have sampled and we have broken it into segments of 2 seconds. So we have used MFCC, MEL frequency Capstrom coefficient for feature extraction. The measuring frequency Capstrom feature extraction is a representation of short-term power spectrum of a sound based on a linear cosine transmission of log power spectrum on a non-linear MEL scale of frequency. Data was very less, so we had broken a large signal in 2 seconds overlapping fashion. Any audio file which is less than 2 second or signal is zero padded and use data for augmentation and shuffling to make data less biased. Methodology: we tried number of combination of DL model. A final model is combination of one-dimensional CNN layers, dropout, max, and fully connected network. We trained a model for 32 epochs and 32 batch size. Model architecture. So here first is the input layer, then we have combination 1D layer, then another conv layer, then we have do max pooling, then dropout. After that we have done con 3D, and then con 1D, then again con 1D, then max pooling, then dropout, then con 1D, con 1D, and max pooling. Again we have dropout, then con 1D and con 1D. Finally we have global max pooling, then dropout, and then we have the dense layers, fully connected layers, and finally we get the output from the dense layer. So during a testing we have results of training accuracy of 89%, testing accuracy of 94%, and accuracy for whole data set is 90%. Result shows that a model doesn't get overtrained as training has some accuracy is less because training accuracy is less because of dropouts. Okay, fine. So we have also made an web app to where you can see you can upload any audio file in WAV format, and
MP3,
or MP3 format, and we can see that, and we can tell you the result whether the heartbeat recorded is abnormal or normal, and it is an abnormal, we can classify it into the 4 categories we found. So we have made an web app through React.js, a web framework for building front-end user interface and host the site. So front-end is made on React.js, and of course the backend is written on Node.js to run the model and to ready the model. We have a Python script. So Node.js basically runs a Python script which in turn the Python script runs our model. So Express.js, a backend web framework from Node.js to handle requests of certain URL in case of upload data and retrieve results, and then to make the backend calls like running the model on the user and generating output. Second, working of the API. User logs in the web app interface which is hosted on server in case in a machine is hosted on port 3000. The UI gives the user to click button to upload the heartbeat audio file. Heartbeat audio file is sent to the URL, and machine IP 8000 upload where the Node.js server handles the request of upload using Express plugin. Express stores the file in local storage and calls a deep learning model to run on the user audio file and return the prediction of heartbeat abnormality with some probability score. This report data is sent back to the Node.js React frontend, then displayed appropriate detailed message of the type of abnormality seen by the user. Now we will show you the demo of the app. So here we can see we can browse an app, browse an file, and we can upload any audio file. Let's say we upload an audio file of unlabeled test. So we open it and we submit the query. Here we can see that the probability score is of 88%, and we have an information of artifact. What is an artifact? We can also try another files. Let's try mama. Okay, we can try a normal file to see that it's running or not. So we get that a normal probability of score 72%. In normal category there are normal hard sounds. We can also try another file. So again we are trying any artifact file. So we get a normal score. So there's some bias in it. Okay. So this was a demo. Thank you.